Section 1.2 is order of operations. And again, this is a topic you've seen before, and we should have no problems with it at all. So, PEMDAS, P-E-M-D-A-S, this is how we remember our order of operations. And if you remember, the P stands for parentheses. We always look at the parentheses first and see if there's anything we can do within parentheses. The E is for exponents. So we're going to work on powers after we do our parentheses. Then we have MD. Now these two go together. They stand for multiplication and division. And we do those at the same time, working from left to right. We'll do some examples of that. And the last two are add and subtract. And again, we do addition and subtraction all at the same time. And again, we work it left to right. So that's our order of operations. I know that you all have seen this before. We worked with it on our circuits a little bit. Grouping symbols, several ways to show grouping. One is with a parentheses, maybe grouping 7 minus 2 inside a parentheses. Sometimes we use a bracket. Again, that can be used for a simple grouping symbol, or sometimes we use it when we have a group within a group. So we use the parentheses inside and the brackets. So these are parentheses, and this is called a bracket. And those all go under that first category of PEMDAS. The other thing that we sometimes use for a grouping symbol is the fraction bar. So if I have something like 3 plus 2 divided by 3, even though division is supposed to come first, this acts as a parentheses. Everything on top is done first, and then we divide afterwards. So the fraction bar automatically assumes that anything at the top or the bottom of that fraction bar is done before, as though you would have a grouping symbol around it. And that's really it for order of operations. We're going to do a few examples. So let's look at this one. First thing we have to do is our substitution, and I want you to write that out so that you know exactly what goes where. So we're going to write 7 in place of A. B is 3, and then 4, and I need an operation symbol here, 4 times 5. So again, working inside the parentheses. So inside the parentheses, there's a few things I can do. I've got 3 cubed minus 20, and I'm going to work over here because I know I have more problems coming. So 7 squared minus, still working inside the parentheses, 27 minus 20. So even though I've done an exponent, I'm not going to do this exponent until I finish all of my parentheses. Now I can do my 7 squared, and I get 42. Alright, let's try this one. If A is 5 and B is 2, again, showing our substitution. I'm going to use dots for my multiplication this time. Alright, so no parentheses, so my next thing is my exponents. Now I'm going to do my multiplication left to right. 3 times 5 is 15, and 15 times 4 is 60. And let's try this one. And if you notice, the only thing different between these two is that this one has a parentheses. So let's see how the parentheses changes things. A times B is in the parentheses. Now, before I do my exponent, I still have to work in my parentheses. So 3 times 5 times 2 is 10. Now I'm going to do my exponent. So I'm not going to multiply the 3 times the 10, I'm going to do the 10 squared. And then multiplication is last for this one. So take a look at these two problems. Adding a simple parentheses changes the problem completely. What I would like you to do is to use this same starting point See if you can put a different set of parentheses in a different position. I put the parentheses around the AB, and see how that changes the answer, still using A equals 5 and B equals 2. So do that on your own before you come to class. Again, using 3AB squared, we're going to put parentheses into this problem anywhere you want in a different position than around the AB, and then evaluate this expression using A equals 5 and B equals 2. And that's it. Pretty quick and simple video.